So the next topic I'd like to talk about is class templates. So why do we want to use class templates? So currently what we have here is a stack. This is a simple stack, and we can use our stack if you remember the design. So the stack is currently designed only to hold floating point data, right? So how do I change this class into a generic class? So once I convert my stack design into a generic class, then I should be able to say something like this. Okay? So then the same class can be used to store int, float, double, character, whatever. Now, just to make my code look the standard way of using the header file in C++ library, so I'm going to use a simple name. I'm not using .h anymore. Okay, so I'm just using stack now, but then I have to create a stack. I need to create a new generic stack. Okay, so I'm going to create a new class. It will be like a new header file actually, and let me create new. Let me just call it source file, because if I say I'm going to create a new header file, Eclipse may complain. So, but what we have here is practically a header file. So, okay. So how do I create a generic stack? So what I can do is I can just copy my stack class. Maybe just copy everything, or maybe start from line 9 and then copy it to the end. Copy and then paste. Okay. Now, if you remember, like on Friday, I give you an example how to make a function into a generic function. So we use the keyword template. So we need to do the same thing. So I'm going to say that this class is a generic class. I'm going to use template. Template type name, and let me call it my item. Okay. So what is my item? Well, my item will be the type that will determine whether the stack is holding a float or an integer or string or whatever. So that means anytime I see a float in here, I need to rename float into my name. So my item. So I have float here, right? So then current is a function that will return the topmost item. So now that function should return my item, not float anymore. Okay. So whenever I push an item, I have to push my item. Okay. When I use the plus operator, I have to use my item again. Okay. So when I pop from the stack, I will get something of type my item. And when I use the operator minus to pop, again using a different syntax, and I'm going to get a reference to my item, and I need to replace that with my item. Okay? Question so far? Yes, Alex.
Say my item pop, which is float pop.
Thank you. Any other question? Okay. So now imagine that float can now be an image. I mean not float, my item, sorry. Because before we have just store floating point data, right? But given the new template, now it is now possible to use this stack class to keep a stack of images, to keep a stack of huge data. Okay? So now you know that whenever you work with huge data, we don't want to use pass by value. Right? We're going to have an overhead when we try to push an item. Because currently, imagine that this is now an image. When you push by value, when you try to pass the item, the image data by value, then you know that the incoming image has to be copied into the parameter, and then it will be copied again into the stack. So twice of copying data. So we want to reduce that overhead. So what should I do to improve the performance of my push? Yes, Joshua. Change it to a reference, exactly. Okay? Any question about why we want to use a reference there? Okay? Because now my item can be any type, not just primitive types, right? Same thing for current. Yes, Joshua.
Have you explained what a friend is already?
Friend?
It's in the homework one. I don't know if you've already explained what it is, but
Okay, a friend function, a friend declaration is applied to a function. Okay, so without a friend, without the friend keyword, so this is just a function that takes two parameters and return an output stream object, right? So why do we need friend? Because this function is not a member function. Okay, this function is a function outside of stack. That means operator shift doesn't have permission to use private data. Okay? That's why we need to declare it as friend. Okay? After I declare a function to be a friend function, now basically we are giving permission to that function to use private data of stack. Okay. Why? Because the second parameter here is a stack, and potentially, if the function operator left shift requires to access the private data of stack, then now the friend keyword allows that function to use private items of stack, either private data or private functions. Okay. Okay. Now, I want to change the return type of current, right? Because why? Current returns a copy of the object on your stack. Again, to improve the performance of my current, I want to return an alias. I don't need to copy. I don't need to make a copy. Okay? Why? Because current will be returning the topmost object. I know that the topmost object is still in my stack. I'm just returning an alias. So whoever calling the function current will get an alias to the topmost object, which is still valid because it's still in my stack. Right? Okay? Question? Okay, now, how about pop? Can I change the return type of pop to reference? No. Good. I like to hear that answer. Tell us why.
Because once you pop it off of the stack, it's no longer associated with the stack, so
Yep.
it has nothing referencing it.
Exactly.
It's loose data.
Yeah.
It's no longer valid.
Yeah. Okay. So I don't want to return a reference after I pop it, right? Because whenever I pop it, then whoever get the value from pop will own that variable, right? So that's why I don't want to return it by reference. Okay? Same thing with my item here. I have to keep it as return by value. So, of course, if I compile, it's not going to work because there are some errors in here. So we know that the way we design, normally we split the interface in .h and the implementation in .cpp. But after you're using generic, you cannot split the two files anymore. You have to write everything into one. Okay, it's not going to work if you split the two files. Then you have to put everything into one file. Okay, so now what I'm going to do, I'm going to disable. If I try to compile, I will get like multiple declaration because I have the original stack CPP and stack.h, and as well as the template, the generic stack. So in order to exclude my CPP into the comparison step by Eclipse, I just need to rename my CPP to a non-C program. So I just rename it to .txt. Okay, I just need to keep a copy of my source code in the same project folder, but I don't want to let Eclipse to include those files when I compile. So just rename it to .txt. Okay, so now the two files are not C++ or C code anymore. Those two files are just text. Okay, now because I need to bring everything into one file, so the easiest for me is just to copy all in my stack CPP into my other file. So I'm going to copy. So if you remember what I did before, I copied the header file, and now I need to copy the implementation file. So I'm going to copy all those functions, Control C, and then move back here, and I put the rest of my source code below the class declaration. Okay, just some cleanup. I'm going to move those 3 lines from here to the top, and I don't need to include IOStream twice, and I will keep everything like that.
You have to get rid of the semicolon at the end of the class stack right there.
Nope,
No?
keep it there.
Okay.
Keep it there. Keep the semicolon here.
Okay.
Okay, if you remove that semicolon, then it will get an error. Okay, now remember, now every function in here, starting from line 44 to the end of the file, each function is now a template function. Okay, so if you remember what I did on Friday last week, in order to change this function into a template function, I have to use the keyword template for each of them. Okay, template, type name, okay, but the good thing is I don't have to use my item. I can just use any character. As long as you're consistent, okay, but if you're too lazy to type, you just replace that, my item, with something, okay? So then you have to do that for each function, right? For each function. So because the template declaration is like part of the signature of all the methods. If I try to compile, you will get an error, okay? But let me try to compile this, and of course now I don't want to use the other stack, because my stack is now a generic stack. Whenever I declare a stack variable, I need to use the element type in my brackets. So this will be like a stack of integers. And if I try to compile, I'll get a lot of errors. Okay? Tons of errors. The reason is because we are missing a lot of them. Okay? So what's wrong with that? So we know how to declare using the scope name, right? But now my stack is not a pure stack anymore. My stack is a template stack. So then I need to include the type name as part of my scope. Question. So you need to repeat that for each function. Okay, you need to repeat. So now the scope has to be suffixed with angle bracket my item. Okay. All of them. I can also make it a different letter. I don't have to use my item. I can just use M. Okay, and for all of them, as long as you use the same type name in your template, just use M there. Okay, and again, it's not complete. You will get errors. What's wrong with that? Because now the type is not float. The type is my item, right? Okay, and compile again. So then you will get errors in other places. Okay, what's wrong with that?
You just added the bracket.
I have an extra curly brackets there. And now the type, the stack is not stack. It's not a pure stack anymore. But again, the stack input parameter is actually stack of M. right? Same thing with the return. That's like a stack of M now. Okay, so when I compile, yep, no error in my stack, and my main compiles as well. What's wrong with my push? My push looks correct here. My item void push. Okay, what is the error now? Oh, because I'm using a reference. So because I'm using a reference, then I need to use a variable. Okay, so then I have to say val equals 12, and then vals equal 20, and I use as val. Thank you. Compile, and it should work. Yep, so then I can run. Okay, as soon as you have a class that overloads the operator parentheses, and we know that operator parentheses is function call, then you create a functor class. So let me create one here. Let me create extra one here. So I'm going to create a functor class. Let me call it sum3. Okay? And inside this function, inside the class, this is a class, this is not a function. And I need to create a public function, and that function is operator parentheses. Okay? Question so far? This is a function, right? And the function may take several arguments. And you know the function has a body and the function has a return type. Okay? Now, I name my class sum3 because my intention is to make this function to add three numbers together. So what I want to do here is I'm going to declare three input parameters, let's say integers. Okay? And what do I write inside the body of this function? Return a plus b plus c, and what will be the return type? Int. Yep. Okay, that's one function. I can create another one. Let me call it product3. And you can guess, in my product3, I'm going to overload the operator function call again. Okay, and let's say it will take three arguments, x, y, and z. And it will return what? X multiply y multiply z. Any question about the two classes here, sum3 and prod3? Okay, so I just create a function, a class, and the only thing I have in my function in my class is one function. That function is the operator parentheses. Yes, Ryan.
Could you just clarify why you had to make a new class? Like why you couldn't just put the function instead of making a new class?
Okay, if I create a function like that, is that what you're asking me?
Yeah.
Okay. Add 3, not 3, add 3. Add 3. So add 3 is a function, but it doesn't look like an object. Because my goal is to create a function that looks like an object. Okay? So that's why I don't want to use a standalone function. Just coming it out here. I don't want to use a standalone function, but I want to use a class that will look like a function. So then in my main, now I can say I have an object whose type is sum3, I call it adder. And I have another object whose type is prod3, and I call it multiplier. Okay? So now, adder is an object that behaves like a function. So when I want to do the operation, I have to say operator, and I can just supply 3 numbers, right? Adder, yep, that's correct. The function name should be adder, the object name is adder, and I will get a result. Okay? Any questions so far? So I'm calling that function, my function name is operator parentheses, exactly the name of that function here, right? But you know that the shortcut of calling that would be just function call. I don't have to say dot operator parentheses. Right? Exactly like we use our here, right? Before we have brackets, square brackets, replace that with parentheses. Then basically the syntax is the same. Okay? Question? So now I can repeat the same logic for the second function, the second object, the second function object. Okay? So my object looks like a function. My function is now an object. Question? So I mentioned before, one of the benefits of designing a function into an object, so now we can send a function object to another function. So let's say I'm going to add another function. Let me call it doMath. So my doMath will take 3 arguments. And now I want to say, okay, this time I want to add those 3 numbers. Okay, and the next time I'm going to pass 3 numbers again. But the second time I call doMath, I want to multiply them. Okay, so now it is now possible to do that because I make an object that looks like a function. My function has been packaged as an object. Okay, question about the doMath function? So now the question is, how do I write my doMath? So maybe like I just need to declare doMath to return void, and it will take 3 numbers. Okay, v1, v2, and v3. But now the question is, what do I put? How do I declare the last parameter?
We call it an object.
Object. Okay. Like that?
Yeah.
Okay? It won't compile, unfortunately. If you compile this in Java, it will compile. Because we know that in Java, object with uppercase O is the root class of all object hierarchy, right? but unfortunately, we don't have object in C++. Kyle.
Can you use auto?
Okay, can we use auto?
No.
Okay, does it compile?
What if that int to v3?
Okay, close, but it doesn't compile.
We also haven't specified the type of v3.
Type of?
v3 in the parameters.
You got.
We have
Oh,
int.
oh, oh.
Okay.
So not auto, not object. Then what? Hmm? Class? Like use the keyword class? Like that? Okay? Doesn't like it either? Any more input? Sum 3? Okay? So if I do that, it will compile on the first one, but it doesn't going to compile for the second one. So, what should we do?
Should we put both of those inside of a class on its own? Like both sum3 and
Could you,
Make sense?
could you define two prototypes for that function?
Okay. Define two prototypes. I agree. That works. So then you will say one prototype will take sum3 and the other prototype will take prod3. Okay? It works, but if you add more function objects, you have to declare another prototype. Okay? Yes, Rain.
You can do it like a template.
Yes. Template. So the answer is template. So instead of copy and pasting the code for do math, one for sum3, one for product3, then what we can do is use template. Okay, so now I'm going to templatize my function. I'm using a symbolic name. I call the symbolic name function of 3. You know why? Because the fourth parameter of my do math is something of type function of 3. Okay? So now after I declare my do math to take a template parameter here, then the two lines will compile with no problem. Okay? So what happened here, when we use template, the compiler will generate the two copies of the do math function for you. Instead of you yourself making copy and paste two different copies, then the compiler will generate the two copies for you. So this is a more flexible technique because as soon as you add the third function object, the same template will work without any problem. Yes?
So if there is one more, then
Okay, so you want to add one more function class? So tell me what function you want to use here? Subtract 3, and you're going to overload the operator to take 3 arguments. Yep. Okay, that works. And what do you do in here? Return A minus B minus C. Yep.
Return type.
Return type, exactly. The return type is an integer. And the same template function. And now I can now declare another object. I'm kind of hungry. Okay, so then I can now call do math again using the third function object. Yes. It works. Okay, any question? Yes.
So if we were to add a fourth class with 4 parameters,
Ah.
right?
That will not work.
Okay.
Okay? Well, so far it will work, but let's write the body of do math so then you can see why it doesn't work. Okay? So what do we put in here? So let's say I'm going to store the result into a local variable, right? So I'm going to call result. Okay? So now how do I call the function?
If you that name,
Func object, right?
yeah.
Func object, and I have to pass v1, v2, v3. Okay, and then just type print the result. The result is result. Okay, so far so good. But now if I add another function, if I add another function class that takes 4 parameters, immediately my do math is not going to work. Okay, because that's why I use the symbolic name function of 3, just to remind you that whatever you pass there should be a function that will take 3 parameters. Okay? Question? Does it make sense so far?
What's the benefit of all this?
Okay, what's the benefit of later in chapter 3 or 4 you're gonna see. I'm not going to answer your question today, but briefly the answer is, I give you a hint before. Let's say now I have a collection, data structure collection, right? So now you want to sort your data using some logic. Let's say you have a collection of name, address, salary, and whatever. Okay. So at one time you want to sort the data based on the salary, and at other time you want to sort the data structure, the data using the age of the person and whatever, right? So now we can now send a function object, the sorter function object, to your data structure. So now you can perform different operations, right? Because the benefit of having a function class or function object is your ability to package a code into an object that it can deliver to a function or a class or whatever. Okay? Any other question? Okay, so now, so far, my function works only for int. My function works only for int. How do I change my function to handle different types of data?
What if you use another template?
Use another template. Exactly. So what I can do now, I can now change the design of my product 3, sum 3, whatever.
You use a template to design those.
Yes. Okay, so now you can apply a template to your class. Let me call it x. Okay, so now every time you have an integer, you replace that with x. Make sense? This is not in the video, by the way. So when I record my lecture on Friday with the other section, I didn't show you the template for a class, but I showed them the template to modify the stack that we used last week. Okay. So any question about changing the class sum3 to make it a template class? Yes, right.
That's only for that class, right?
Yeah, exactly. So then if you want to do the same for prod 3, then you need to repeat the template. Type name. I don't have to use a different letter. If I want to use X again, that works as well. Okay. Because the template declaration applies to the next immediate structure. So then I can use X again, and I'm going to replace that with X. Same thing here. Then I can say template, type name. Let me use Z, and I'm going to replace int with Z, int with Z, int with Z, int with Z. Nothing changed there. But now when I declare my sum3, then I have to say I need to include the type that I want to associate with my sum3 to take the sum of 3 floats instead of int. Yes,
So
question?
when you pick the name for the type name,
Yep.
that's always capitalized?
The coding style is use capitalized, but it doesn't have to be a capital letter. You can use any name, any valid identifier in C++. That's it.
When you make a template X, in place of int, do you have to replace it for every single?
Yes. Well, not every single. If your intention is to return, because it is possible that you can
So, yeah, just the X that you just pointed
Yeah.
at.
Like
Yeah,
here.
that one, yeah.
Yeah.
If that was int, that would be okay, right?
right. But that means the function will always return an int, regardless of the input ABC that you supply to the function. Right? If that's what you want to do, yeah, that's fine. Okay? So now, then I need to parameterize my prod3 with float and that with float as well. Okay? Question? So apparently then I don't have to templatize my function object. C++ compiler is smart enough to know that the function that the function of 3 is actually a templatized function, right? A templatized object, I mean, well, function object now, right? Jesse?
So then the float's just what we're making X then? We're making that a float. The type. So instead of an int, it's float. Like that.
Here?
Yeah.
Yeah, you then should be able to use different type. Is that what you're asking me?
Yeah, okay, there we go.
Yeah.
Do you have to change your do math then?
Nope.
Because you said int there instead.
Ah, you're right. Well, not the way I do it now. Okay, not the way I do it now. Why? Because when I call do math, the first 3 arguments are integers. Right? Okay? So my do math definition works fine.
But if you were to have a decimal point.
Yeah, exactly. Okay? So because now the way I call do math, the first 3 integers are the first 3 arguments are integers, my do math works fine. But as soon as you do something like 2.57, then it may not like it. If I recompile, yeah, because now adder is a float, right? So the result has to be float. And the next line has to be float.
But just saying those are unused.
Oh yeah, okay. And so far we don't have any problem passing 2.57. I guess what will happen is the input will get truncated to 2, right? Because the input to do math are integers. So in that case, the 2.7 here will get truncated into 2, and we will get a number, but the result will be incorrect, kind of incorrect. Okay? If you do want to make do math takes any type, then again, you just need to declare a second type name.
Same as above in the.
Yeah, let's call it data, and then you replace int with data, and then data, and then data, and result will be data. Okay?
That's what I was wondering.
Yep. So you can put as many as type name arguments inside the square angle brackets of the template. Any question? Yes, Ryan.
I don't, can you explain what the sum3 float, why do you have to put the float there? What are
Okay.
you doing exactly?
Okay. Because as soon as I change my class sum3 to be a template class, every time I declare sum3 object, I need to specify what goes into X.
Okay.
Okay? Because now sum3 is a class that takes one template argument. Okay? So now with that X here, okay, because now my sum3 is a class that takes one type argument. So then when I declare my sum3, I need to put something in angle bracket. Yes?
How are the two type names determined as far as order? So how does it know what to put in function of 3 and what to put in def? For your do math function.
The type is inferred by the compiler. Okay? The type is inferred by the compiler. So let's take a look at the call here, right? When we call do math, the first 3 parameters are integer, okay? And we know that the first 3 parameters are of the same type. Then the compiler will generate one version of do math that will take 3 integers. And the fourth parameter here is adder. And adder is what? Adder is a template class sum3 parameters by float. So then throughout this do math, function of 3 would be sum3 float. Okay? Did I answer the question? The order of the two type name doesn't matter. You may switch them. Okay? C++ compiler is smart enough to know which one is which. Okay? But let's say if I use another type name y on my sum3 and I just make up something. Let's say I'm going to be using y to declare an instance variable that I don't use. Okay? Just to give you an example, that the order of xy here is important. Why? Because now my sum3 class is a class that takes 2 template arguments, x and y. So the first type would be the type of the input parameters and the result. But the second type will be the type of my private data. Okay? Then, because of the second arguments, template argument xy for sum3, whenever you declare sum3, you have to supply 2 types. It's not going to work if you just apply 1. Let's say the second type is a character. Again, my example doesn't make sense. I mean, I'm not using that character for anything, but just to show you that the order here is important, because it will determine how you specify your type. Okay? But the order of the type name here is not that important. Okay? The compiler will infer the type from these 3 lines. Okay? Any other question? Next question. Yes, Ryan.
So if you wanted to do like adding on float and int, you'd have to create a new sum3 object that was int.
Yeah.
Instead of float.
Yeah.
You'd have to do
Yeah.
okay.
Yeah. So if the pattern, because template basically just pattern matching. Okay, the way the compiler handle the code generation is just template matching. So whenever the type of your, the pattern of your template doesn't match the intention of your function call, then the compiler will say, I don't know how to generate this function. Okay, so yeah. Any other question? Okay, so now you know how to create a template for your class. You know how to apply template to a function, apply template to a class. Let's start with another example. So what I'm going to do, use Eclipse. So this is our main, and my main is a very short example of how to use stack. Okay, this is the same stack that I've been using in the last 2 weeks. And I'm going to change the design of my stack into a template class. Okay, so you know how to use template with function and class, and what I'm going to do is I'm going to delete the declaration of stack as, because now I'm going to change my stack into a template, and it will take an additional parameter. So I can now say I want to create a stack of int, I want to create a stack of string, okay? So I can create a stack of anything. So now, to keep the same style of using a header file in C++ library, I'm going to delete the .h. So normally you name your header file using .h. So I'm going to delete .h. Okay. So I'm going to now create a header file, but that header file will be my template for my stack. Okay. So let's do that. So I did this in my 3 p.m. section. I'm going to repeat the step again. So I'm going to create a new header file because I'm using a header file without the extension .h there, and create a new file. Normally when you create a header file, you will select this menu item, header file, but Eclipse may complain because I'm not going to use .h as the normal extension name. So instead of selecting a header file, I'm going to create a source file. And I'm going to call it stack. Okay, but this is a header. Okay. Now, normally I've been using the split design for my class. We split the interface into .h and we put the implementation into .cpp. When you templatize your class, you have to put everything into one. Okay, so you cannot split the design into two separate files. You have to put everything into one. That's why I don't want to use .h. I want to name my file just stack, because I have to combine my function definition and my class declaration into one. So what I'm going to do is I'm going to copy the header file. Okay, so I have the original header here, stack h.cpp. So let me open it. So this is what you have been we've been using in the last 2 weeks. So this is the class, the stack class definition. I'm going to copy everything, highlight from line 9 to the end, copy, and I'm going to paste everything into my stack. Okay? But now I'm going to change my stack into a template. So I need to add a keyword template, right? Type name, and let me use some data. Okay? Question so far? Everybody's following what I'm doing? So what else do I need to update inside my class declaration? Which line number do I have to update? 20 what?
Wait, you're making it so the stack works with
Any type, yep.
So, yeah, 28.
28?
Load
Yep. I want to change that to
data,
data. Yep. Okay. What else?
30,
30 data.
and then
What else?
32.
32,
You gotta get 31,
31,
27, and 2.
31, 29, and
27.
27.
And what about below?
35. Exactly. Okay.
Is that-
Question. Am I missing something? So far, so good. Okay. Let's make this more efficient. So what's wrong with line 28? What's wrong with line 30? What's wrong with line 27?
take, well, we gotta, where the actual code is, we gotta change.
Yep, we don't have the code yet. I will include a code later. Okay. Imagine if I create a stack of images. An image is a huge object, right? And when I try to push a new image into my stack, when I call push, the image object will be passed to my function by copying. I don't want to pass by copying the parameter. I want to make it more efficient. How? Yeah. I want to use ampersand there, and I promise I'm not going to alter that object. So then I'm going to use const reference. Question? Same thing with operator plus, right? Because you're pushing an object, I want to make it more efficient by declaring as a const ref. Okay? Current, same thing. I need to change that to reference. Question? Anything else I can optimize?
What about your pop?
Pop. Can I change that to a reference? Can I?
Can, I wouldn't recommend it
Why?
though. Because it's gonna leave a reference to a location in memory that if that item ever gets deleted.
Right,
you're
right, right.
full.
Exactly, right? When I pop an item from the stack, we are going to remove the item from the stack. If you return an alias, well, what happened? The item is not in the stack anymore, and now you're returning an alias, then we're going to have a situation of dangling alias, right? So we don't want to do that. We don't want to do that here. So we have to return value. We have to return by value. Because you're going to remove an item from the stack, and that item will have to be copied into whoever calls pop. But the story is different from current. Current is just returning the topmost item. It is okay to return the alias of that topmost item because we know that the item is still in our stack. So returning an alias is not going to give you a dangling alias problem. Okay? That's what we want to do here. We don't want to return by value because it's inefficient. We don't want to return by reference here because it will give you a dangling reference. Okay, same thing with that. I don't want to change it, turn into a reference. So now once I have the template, I changed my class declaration to a template, then the next thing I need to do is to copy the function definitions below this file. Remember, I just mentioned to you, when you change your design of your class into a template class, you have to put everything into one big file. Okay? Compiling template takes longer, but it's worth the effort because you don't have to copy, you don't have to replicate your stack, one for integer, one for float, one for character. You just use one template that you can use for any different data types, right? But I do have to copy the function, what we used to see inside the .cpp, inside this file. So that's what I'm going to do now. I'm going to highlight my, so this is, I'm opening the .cpp file. So I'm going to copy everything from line 10 all the way to the end of the file. And then just say copy and paste into my template file somewhere in here. Okay. Yep. And now I want to move those 3 lines from there to the top. and I don't need the second include, I don't need the second using namespace, and so far it's good. Okay, and you know how to make a function into a template function. I have to repeat the keyword template for each function, right? So because now I have my stack, and I need to say template, type name, we use data there, and you have to repeat that line for each function. And let's compile. We will get tons of errors if we compile. Okay, let's see. Okay, so we have tons of errors because the constructor is unknown. Okay, we do have the template, but we also need to tell the compiler, because now my stack, the type of stack requires an angle bracket, right? So whenever I use stack for scoping my function, I need to put something in there. Okay, and when I, instead of creating an array of float, I need to create an array of data, right? And same thing here, I have to change the scope to angle bracket data, and if I recompile and make sure that those lines are okay, yep, I need to do the same for the rest of my function data. So I need to change the scope. Okay, I need to change the scope, but it's not enough. I have to also change that to take an angle bracket, right? Because now the context here is, now I'm passing a templatized stack. It's not a pure stack anymore. So I need to put a bracket there.
You have to do the return value too?
Yes, exactly. I need to do a return value there and here, and last one. Okay, and I need to change it to a template, right? Template type name data, and everything will compile. Yep, and my main will compile. Yes, so it worked.